Hey there, class! Today we are looking at exercise 8b, recurrence relations. So recurrence relations are mathematical rules that are used to generate sequences. In our last exercise, we looked at writing sequences from a sentence. Okay, so here is the starting number, this is the rule. We're now going to express those rules mathematically. So every sequence has the form V0 equals A, where A is just the initial term, V0 meaning initial value. Okay, so V stands for value, V0 initial, Vn plus 1, okay, equals Vn plus D. So this is the next value, okay, n plus 1. Vn is our current term. N plus 1 means, well, we're adding 1 to that term, so we're moving to the next term. D is just the difference. So are we multiplying, dividing, adding, subtracting? It's whatever the change is between each number in the sequence. So we'll give it a shot ourselves. I've got two examples for you today. We're going to write down the first 5 terms in the sequence. And the sequence is stated here. So V0 equals 1. Vn plus 1 equals Vn times 2. So I'm going to write the sequence is, just because. You could jump straight into writing it. Okay, the sequence is, the initial value here is 1, so we're going to start with 1. The second number, so n, if it's 0, n plus 1, v1, or the first value, the next value is 1 times 2, which gives us 2. The third value, or the second term in the sequence after the initial, okay, we then multiply this number by 2. So each single time that we go across, we are multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So here the difference is, same as what we did in our last exercise, we are multiplying by 2. Oop, that's a bit of a funny way to draw an arrow. Every single time. Okay, so starting from the initial value times 2. And that's how we write the sequence out as we did in exercise 8a, but from a rule. Let's try it with a slightly trickier example. This is trickier than any of those in your textbook, but it's a really, really good example of sequences. Okay, we're going to write down the first 7 terms in this sequence. So here we've got V0, so the initial value is 0, and V1, so the first value after the initial, is 1. With the rule, Vn plus 1, so the next value, equals Vn, the current value, plus Vn minus 1, the previous value. Okay, so the next value is given by the current value plus the one that preceded it. So the sequence is, okay, the initial value is 0. The first value is 1. And then we'll keep going. So to find the next value, we need to add these two. So 0 plus 1 is 1. To then find this next value, we need to add the last 2 terms. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. And for our 7th value, 3 plus 5 is 8, and it continues. Okay. So we've got the first 7 terms in the sequence, okay? So we added these 2 terms to give this. We added these 2 terms to give 2. These 2 to give 3. A much trickier example, this here is called the Fibonacci sequence, okay? It's one that appears really, really frequently in nature, okay? Which is why I chose it as an example. And that's all there really is to it. So following the rules, we add these 2 to give this, we then add these 2 to give this, we then add these 2 numbers to give this, and it continues on, okay? And that's all there is to recurrence relations. Give it a shot for yourselves. Always feel free to message me if you have any questions, and I'll see you guys in a conference call soon to help you all out. Good luck, guys.